Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to explain you the concept of TLS Record Protocol Operation. TLS Record Protocol Operation. So TLS stands for what? Transport Layer Security. So which is one type of security that provides upper layer of the transport layer. Upper layer of the transport layer. So the TLS Record Protocol provides two services that what we explained in the previous session, TLS connection, TLS sessions. So the two services for TLS connection is what? The confidentiality and the message integrity. The services for TLS connection is what? Confidentiality and the message integrity. So here the confidentiality. The handshake protocol defines a shared secret key. A shared secret key that is used for conventional encryption of TLS payloads. That means transport layer security payloads that having loading the data. So all the payloads are having the different types of data. So that is the payloads. They are having different types. And second one is message integrity. The handshake protocol also defines a shared secret key that is used to form a message authentication code. So one is used for conventional encryption purpose, and the second one is for forming a message authentication codes. So generating message authentication codes for one point, and the conventional encryption of TLS payloads is one point. So for these two services, the TLS record protocol provides. So the TLS record protocol takes an application message to be transmitted, fragments the data into manageable blocks, optionally compress the data, applies MAC, encrypts, add header, and transmit the resulting unit in a TCP segment. Received data are decrypted, verified, decompressed, and reassembled before being delivered to the higher level users. So the record protocol, the TLS record protocol takes some sort of phases that are, first one is what? Application message to be transmitted, and that fragments the data into manageable blocks. The next optionally compress the data. The next applies MAC, encryption, header, transmit the resulting unit into TCP segment. Then after that, received data are decrypted, verified, decompressed, and reassembled before delivering the data to the next levels. So here we will see the TLS record protocol operation. So this is the application data which is going to be transmitted for the next level. And that data is going to be divided into some blocks, that each and every block is called as fragment. After that, after dividing that blocks, doing the compression for reducing the size. The next, add message authentication code. After adding the message authentication code, the encryption process will be done. After doing the encryption process, append the TLS record header. So these are all the phases that are having the record protocol. So what are those phases? First one is what? Application data is going to be divided into application data. First of all, taking the phases, application data is to be transmitted, and then dividing the application data into different blocks is called as fragments. And each and every block is going to be compressed. Then add MAC to the compressed data. That is nothing but message authentication code to the compressed data. Then next, apply the encryption process for message authentication code data. Then next, append the TLS record header to the encrypted data. So these are all the phases that are applying for the data transmission to the next layer. So here the first step is to fragmentation. So each upper layer message is fragmented into blocks of 214 bytes or less than bytes. Next one is what? Compression. The first one is what? Fragmentation. The next one is what? Compression. It is optionally applied. And compression must be lossless and may not increase the content length by more than 1024 bytes. And more than 1024 bytes. In TLS v2, no compression algorithm specified. So the default compression algorithm is null. The next step is processing into compute message authentication code. Computing message authentication code over the compressed data. So applying MAC before encryption, after compression and before encryption. Message authentication code has to be done. And TLS makes use of the HMAC algorithm defined in RFC 2104. That is nothing but request for comments 2104. And recall from chapter 12 that HMAC is defined as what? HMAC K of message that equals to H of K plus of OPAD, optional pad, H of K plus of optional pad and message. From this formula where H equals to embedded hash function for TLS, either it is a MD5 function or SHA1 function. The next M equals to message input to the HMAC. Message input to the HMAC. And K plus A is the secret key padded with zeros on the left so that the result is equivalent to the block length. Result is equivalent to the block length of the hash code. And the iPad is what? 00110110. And repeated for 64 times, that is 512 bits has to be calculated. And output pad, so that is optional pad 0101 1100. 5C is in hexadecimal and repeated 64 times for 512 bits. And for TLS, the MAC calculation encompasses the fields indicated in the following expression. So the following expression is what? Hash authentication function, hash function. So HMAC of underscore hash of MAC write secret, sequence number, TLS compressor dot type, TLS compressor dot version, TLS compressor dot length and TLS compressor dot fragment. So these are all the fields that are having the TLS connection and session parameters. Connection and session parameters. So with these parameters are loading. They are going to take the data to the specified type. They are going to take the data for which specified type. For which specified type. The MAC calculations overall the fields XXX something plus the field TLS is compressed. Plus field TLS is compressed. So suppose 101 is a field that will be added to the TLS compressed version, which is the version of the protocol being employed. Next, the compressed message plus MAC are encrypted. So whatever the MAC authenticated, that will be compressed before doing the MAC. After doing the MAC and compressed plus MAC data is going to be encrypted. Compressed and MAC data is going to be encrypted using symmetric encryption. So encryption may not increase the content length by more than 1024 bytes. So the encryption code may not be increased the content length by more than 1024 bytes. So the total length may not be exceed than 214 plus 2048. The following encryption algorithms are permitted. So because of these size issues, we have to use some certain types of algorithms. So the AES, advanced encryption system is one algorithm, and triple DES, 3DES, data encryption standard is one algorithm, which having the key size of 128.256 and 168. And the stream cipher, in this stream cipher, RC4 algorithm, RC4 to 128 is one algorithm, which having the key size 128. So for stream encryption, the compressed message plus the MAC are encrypted. Now, for stream encryption, the compressed message plus MAC are encrypted. The MAC is computed before encryption takes place, and that the MAC is then encrypted along with the plain text or compressed plain text. So if it is compressed, if it is MAC authenticated, if it is encrypted, so before encrypting it should be authenticated with the compression data, authenticated with the compression. Before encryption takes place, the MAC is then encrypted along with the plain text and the compressed plain text. So for block encryption, a padding may be added after the MAC prior to the encryption. So for the block encryption, the padding may be added after the MAC prior to encryption. So before encryption and after MAC, this padding may be added. The padding is in the form of a number of padding bytes followed by 1 byte indication of the length of the padding. 1 byte indication of the length of the padding. So the padding can be any amount of results in a total, that is multiple of ciphers block length. So which is up to 255 bytes. For example, if the cipher block length is 16 bytes, and if the plain text plus MAC plus padding length byte is 79 bytes long, then the padding length can be 1, 17, 33 and so on. Up to 161 it is added. At a padding length of 161, the total length 79 plus 161 equals to 240. The total length size is what? 79 plus 161 equals to 240. A variable padding length may be used to frustrate attacks based on analysis of the length of exchanged messages. So the available padding length may be used to frustrate the attacks based on analysis of the length of exchanged messages. So the final step of TLS record protocol processing is to prepend a header consisting of the following fields. So what are those fields? So we'll see. First one is what? Content type. The higher layer protocols used to process the enclosed fragments, and major version, that indicates major version of TLS in use. For TLS v2, the value is 3. And minor version, it indicates minor version in use. For TLS v2, the value is 1. And compressed length, which is having 16 bits, the length in bytes of the plain text. And fragment or compressed fragment, if compression is used. If it is not compressed, then it is normal fragment. If it is compressed, then it will become as a compressed fragment. The maximum value is what? 214 plus 2048. The content type that have been defined are change cyberspec, alert, handshake and application data. So these are all the record protocol operations that are having different content types. Here the first three are the TLS specific protocols. What are those? Change cipher protocol, change cipher spec protocol, alert protocol and handshake protocol. These three protocols are TLS specific protocols. In that first one is what? A change cipher spec protocol. The change cipher spec protocol is one of the 4 TLS specific protocols that use the TLS record protocol, and it is the simplest. This protocol consists of a single message. A single message. which consists of a single byte with the value 1. So the protocol consists of single message and which consists of single byte with value 1. The sole purpose of this message is to cause the pending state to be copied into the current state. So pending state to be copied into the current state, which updates the cipher suite to be used in this connection. So here this is the TLS record format, so which contains what? Content type, major version, minor version, compressed length, and this is all plain text which is optionally compressed. And here the MAC will be added. So this is all nothing but encrypted data. And here alert protocol. So the alert protocol is used to convey TLS related alerts to the peer entity. So TLS related alerts to the peer entity. As with other applications that use TLS, alert messages are compressed and encrypted. So as specified by this current state. So here change cipherspec protocol which contains one field and which is the size of 1 byte. And second one is alert protocol which having the two fields, one is level and second one is alert, which having the sizes 1 byte. And third one is handshake protocol which having the three fields, type, length and content, having the sizes of 1 bytes, 3 bytes and greater than or equals to 0 bytes. Last, this is OPEC-Quant, that is nothing but other upper layer protocol such as HTTP, SMTP, like that. So this is one field OPEC-Quant which is greater than or equals to 1 byte, So here each message in this protocol consists of 2 bytes. That what we shown in the previous slide. The first byte takes the value warning 1 or fatal 2. The convey the severity of the message. If the level is fatal, the TLS immediately terminates the connection. So it gives the warning. Or fatal. If it is fatal, then the TLS immediately terminates the connection. Other connections on the same session may continue, but no new connections on this session may be established. So other connections on the same session may be continue, but no new connections will be added to continue. The second byte contains a code that indicates the specific alert. So here examples of fatal alerts are like bad record MAC, that is nothing but incorrect MAC was received, and handshake failure, that means the sender was unable to negotiate an acceptable set of security parameters given in the options available. An example of warning alert is unsupported certificate. It displays the certificate is invalid, the certificate message is invalid. So like that. And here unsupported certificate, the type of the received certificate is not supported. So this is all about TLS record protocol operation. So once again we will revise the topics which we discussed in this session. So what is the topics we discussed in this session? So here the TLS record protocol provides what? Two types of services. One is the TLS connections and TLS sessions. TLS connection and TLS session. So TLS connection and TLS session. So here for the connection and the session there are separate parameters, but all these TLS connections are made up of with the help of the two services called as confidentiality and message integrity. So here the confidentiality is nothing but what? Handshake protocol defines the shared secret key. So that is used for both sender and receiver. Which is confidentiality. And second one is what? Message integrity, which defines a shared secret key that is used to form a message authentication code. That is used to form a message authentication code. So here, to do this protocol operations, we are having a different phases. That is, first one is what the application message is to be transmitted. First one is what the application message is to be transmitted. Then after that, the message which is having the message is going to be divided into the fragments. That is, fragment is nothing but manageable blocks. That each and every fragment is called as manageable blocks, and which optionally compress the data. And applying max encryptions, add header and transmit the resulting unit into the TCP segment. So received data also decrypted, verified and decompressed. So here, this is the diagram for the TLS record protocol operation. So first is what the main application data. The main application data which is received at this level is going to be divided into some blocks or some fragments. Some blocks or some fragments. So after that, each and every block or each and every fragment is going to be performed compressed. After compressing the algorithm, after compressing the data, apply MAC function. So this MAC is limited for the different algorithms with the help of sizes. Limited for different algorithms with the different sizes. So after applying the MAC, it is going to be encrypted. So with the help of some encryption algorithms, it is going to be encrypted. After that, appending the TLS record header, which is having a different TLS fields. So here, what is the MAC function? So MAC function indicates that what HMAC of M, that is nothing but applying message with the help of hash function, and equals to h of k plus or minus OPAD, h of k plus or minus IPAD. So one is what IPAD, that is input pad, one is what OPAD, that is output pad, and with the message. So here some of the parameters are there. So where h equals to what? Embedded hash function. H is equals to embedded hash function, and m equals to what? Message input to the input message to the HMAC. And next, k plus equals to secret key padded with zeros. On the left, so that the result is equivalent to the block length. And m equals to message input to HMAC. So here the input pad equals to 00110110, which is 36 hexadecimal, which is repeated 64 times. And similarly, OPAD, optional pad, which is 5 hexadecimal, which is repeated for 64 times, 512 bytes. And here the hash function MAC calculation encompasses the fields indicated in the following expressions. So one is HMAC hash authentication function, which is having the MAC write secret is one parameter from TLS session, one parameter from TLS session, and the sequence number is also from there. And TLS compressor dot type is one parameter. TLS compressor dot version is one parameter. TLS compressor dot length is one parameter. TLS compressor dot fragment is also one parameter. So all these parameters are used for calculating the encompasses of the fields that are indicating the expression. So here we're having a different sizes for the block cipher algorithms. Examples are AES and triple days are other algorithms, which is having the sizes of 128, 256, and 168 is the key size for triple days. For the stream cipher, RC4 to 128, RC4 does 128. The key size is what? 128. So for stream encryption, the compressor message plus MAC are encrypted. For stream encryption, the compressed message plus MAC are encrypted. And here we all seen that the block encryption and the padding length, padding can be amount that result in the multiple of cipher's block length up to maximum 255 bytes. So it specifies the length of each and every padding length. Each and every padding length and block length, it specifies that. So here the final step of TLS record protocol processing is to prepend header consisting of the following fields. So what are these fields? Which is having content type of the field and a major version of the field, the next minor version of the field, the next compressed length of the plain text, and which is going to be fragmented, and the maximum value is 214 plus 2048. After this, it is going to be compressed. And here the content types have been defined as change cipher protocol, alert protocol, handshake protocol. So here change cipher protocol is one of the TLS specific protocol, uses the TLS record protocol, and it is a simple one, and which is having the TLS record format, also content type, major version, minor version, compressed length, and a plain text, and a MAC 0, 16, 0 or 20 bytes. So these are all the change cipher protocol fields and the record protocol format fields. And alert protocol also same, it is used for conveying the TLS related alerts to the peer entity. TLS related alert to the peer entity. And as with applications that use TLS, it is compressed and encrypted. So the change cipherspec protocol contains one field which is having 1 byte. Similarly, alert protocol also having two fields which is having level and alert, which is having the size of 1 byte and 1 byte. And similarly, handshake protocol is also having one type, three fields, which is type, length and content. Type, length and content, which is having the sizes 1 byte, 3 bytes and greater than or equal to 0 bytes. And fourth one is other protocols such as HTTP or SMTP protocols, which is having the opaque content, which is the length of greater than or equal to 1 byte. So here from that figure we understand that what the first byte takes the value of warning or fatal. So if the message is fatal, if the level is fatal, TLS immediately terminates the connection. Other connections on the same session may continue, but no new connections on the session may be established. And the second byte, contains what? A code that indicates the specific alert. So example of fatal alerts were bad record MAC, that is nothing but incorrect MAC was received, and handshake failures. The sender was unable to negotiate an acceptable set of security parameters given the options available. So an example of warning alert is unsupported certificate. So this is all about the TLS record protocol operations, which is having the phases like data transmission, application data transmission, the next fragmenting, the next applying compression, the next adding MAC, the next apply encryption process, the next adding or appending TLS record header. So these all the phases will be done. With the help of what? With the help of protocols like change cipher spec protocol, alert protocol, and handshake protocol. With the help of two services like confidentiality and message integrity, message authentication code. So this is all about the TLS record protocol operations with the help of the services, both connection and session services with the relevant protocols. That is about TLS record protocol operation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.